In this video, I'll explain about the chapter Limit and Continuity. So to explain the concept of limits, let me consider a function y equal to f of x, which is given by 2 into x. Now in this function, x is the independent variable and y is the dependent variable. That means whenever you change the value of x, then there will be corresponding change in the value of y. So we call y as dependent variable and x as independent variable. Now let's take x is approaching real number 4. X can take any value, any real value. I have taken here x is approaching real number 4. That is like x is close to 4 means neighborhood of the point 4, not so far away, not from -1, 0, 1, 2, not those points, very close to 4. Some values I will give x as 3.9, then y value is 3.9 into 2, 7.8. When x is 3.99, 7.98. Then x is 3.999, 7.998, and this continues. That means you can observe here, when there is a change in x, there will be a corresponding change in y also. As x approaches 4, this is going towards the value 4. Okay. Y also approaches a new value, that is 7.8, 7.98, 7.998. That means it is approaching towards 8. So as x tends to 4, y is tending to, this is read as tends to, y tends to a new value, that is 8. So this is called the limiting value of a function. Here we are not finding what is exact value of the function. At x equal to 4 we don't require. Here we require as x is moving towards the point 4 where the function moves to. Function also moves to a particular value. So where that function moves, that we have to find out. If that function moves to a particular value, then we call it as a limit of that function. Limiting value of f of x as x approaches a, which is equal to L. So as x approaches a means any real number a, then your function also approaches a new real number L, which is written as limit of f of x extends to a equal to L. It is not the exact value of a function, it is the limiting value. It is the approximate value of the function at that particular point. Now when x tends to a, it can reach a either from the left side or from the right side. Any point if you consider, if it is a 4, then on the left you have 3 here, on the right you have here 5. So very close neighborhoods are nothing but 3.99. So it can reach 4 either from the left side or from the right side. Right side means 4.1, then 4.01, 4.001, 4.0001. That means it is moving towards 4. If x is tending towards the point A from the left side, we call it as left hand limit, which is denoted as limit of f of x as x tends to A from the left. So it is denoted as negative sign, not minus a. It is above a, we are denoting minus because left hand side. If x is approaching a from the right side, then it is right hand limit. It is denoted as limit of f of x as x tends to a from the right. So then limit of a function exists only if left hand limit equal to right hand limit. If both exist and both are equal, then that common value is called as limit of f of x as x tends to a. Then that also exists. In this case, in this example also you can check, you can give the values of 4.1, 4.01, 4.001. 4.1 means it is 8.2, then 4.01 means 8.01. So it is moving towards 8. So in this case LHL, RHL both exist and are equal, and the common value is 8. Hence limit of f of x as x tends to 4 is equal to 8 in this particular example. So this is limit of a function. Now how to evaluate limit for a given function? There are different methods. The first method is direct substitution method. Here x is tending towards some value, we will directly take that value of x and substitute in the given function. So it gives you the answer, that is the limiting value of the function. This method usually applicable for polynomial functions because polynomial functions evaluation of limit is always done using the direct substitution method. Here value of the limit is directly available, and this method is applicable when LHL RHL both have the same value, so no need to do it separately. For all these polynomial kind of function, the direct substitution method always works where left hand limit and right hand limit both are equal. Means from any side, if you approach to a point, it will give you the same value for the function. So let us see direct substitution method. Here direct substitution method is done by directly putting the value of x as 2 in the function. When you put the value of x as 2, don't write limit because we are applying the limit now. That is 2 square minus 2 into 2 plus 3 to the power 2 square plus 1. So this is equal to 4 minus 4 plus 3 to the power 4 plus 1. So this cancels. This is 3 to the power 5. This 3 to the power 5. You can evaluate further. You will get a big number, or else you keep as it is. Now second problem, limit of 3 as x tends to 5. When x approaches 5, as this is a constant, there is no x in this function. This is constant function. It is just a 3. It is unaffected now. So even x tends to 5, x tends to 10, any value, it doesn't affect the value of the constant 3 because it doesn't contain x at all. So value of the limit is 3 only. Now in this case, directly apply the limit x equal to 3. So when you apply the limit, don't write limit at 25 minus 3 square, that is 25 minus it is 9, that is 16, which is equal to 4. I am writing only the positive square root of this. So square root of 16, which is equal to 4. Now in this case, limit of the function as x tends to root 2, directly apply x equal to root 2. So root 2 whole square plus 3 divided by 3 minus root 2 to the power 4. This is equal to root 2 whole square. Square root and square cancels. 2 plus 3 divided by, this is root 2 whole square into root 2 whole square. This can be written as 2 whole square into root 2 whole square. So 2 into 2, square root cancel. 2 2s are 4. So 3 minus 4. This gives you minus 5. Now the fifth problem is limit of 1 plus x square so on up to x to the power 100 as x tends to minus 1. So this is equal to limit as x tends to minus 1. Let me write 1 as it is plus x cube plus so on up to x to the power 99. All odd terms I'll write together plus x square plus x power 4 plus so on up to x to the power 100. Even terms together. Now here there are 50 terms and here also there are 50 terms. So when you apply the limit, this is equal to 1 plus, this is odd terms, minus 1 to the power 1 minus 1 plus minus 1 whole cube minus 1 plus so on up to here it is minus 1 plus here it is minus 1 whole square plus 1 minus 1 whole cube, it is minus 1 whole power 4 is plus 1 minus 1 whole power 100 is also plus 1. So here there are 50 terms, here there are 50 terms, all those will cancel. Minus 1 plus 1 minus 1 plus 1, therefore the remaining value is 1. Answer is 1. Now the next method is for indeterminate forms. That is, when the direct substitution method does not work, that means direct substitution method, if it gives the indeterminate forms of the form 0 by 0, infinity by infinity, infinity minus infinity, 0 into infinity, 1 to the power infinity, 0 power 0, infinity power 0. These are called as indeterminate forms. When you directly substitute value of x into the function, if that gives you any one of these forms, then we call that as indeterminate form. So if you get indeterminate form after directly substituting the value of x into the function, then we have to go with some other method to evaluate the limit of the function. Now under that, first method is factorization method. This is usually applied for 0 by 0 form. 0 by 0 indeterminate form. Let's see how to do that. Evaluate, this is the question. Now apply the limit directly by putting x equal to 2. Let's see what happens. 4 minus 4, it is 0, divided by 2 minus 2, 0. So it is 0 by 0 form. 0 by 0 form is an indeterminate form. That means we have to factor these factor this function and get some of the factors removed, then apply the limit. X square minus 4 is x square minus 2 square. Then a square minus b square formula, x minus 2 into x plus 2 divided by x minus 2. Now this x minus 2 cancels. That factor which was making both numerator and denominator 0, that got cancelled. Now apply the limits. 2 plus 2, it is equal to 4. Hence the value is equal to 4. Now consider the second problem. Limit extends to 1, x cube plus extends to is minus 1, x cube plus 1 divided by x plus 1. So in this case, when you apply the limit, now put x equal to minus 1, you will get minus 1 whole cube is minus 1 plus 1, which is 0, by minus 1 plus 1, 0. Again 0 by 0 form. So you have to factorize to cancel out few of the factors. So x cube plus 1, use the formula of a cube plus b cube, that is x plus 1 into x square minus x plus 1 divided by x plus 1. This is the formula of x cube plus 1. So this cancels here, is equal to, now apply the limit. When you apply the limit, don't write here limit extends to minus 1. Minus 1 whole square minus 1 plus 1. So this gives you minus 1 whole square 1. 1 plus 1 plus 1, that is together 3. Now one more problem here. Limit extends to 1. Apply the limit. Always do direct substitution method first. If it gives you indeterminate form, then go for the factorization method. 1 plus 1, 2 minus 2, 0 by 1 minus 5 minus 4 plus 4, 0. 0 by 0 form. So factorization method I will apply. Limit extends to 1. This is these are two are quadratic polynomials. So factorize them. X square plus 2x minus x minus 2 divided by x square minus 4x minus x plus 4. So this gives you limit extends to 1, x into x plus 2 minus 1 into x plus 2 divided by x into x minus 4 minus 1 into x minus 4. So this gives you limit extends to 1. X plus 2 is x plus 2, x minus 1. In the numerator as well as denominator, x minus 1 is common here. I will cancel out. The remaining is x plus 2 divided by x minus 4. So apply the limit. 2 plus 1, 3 divided by 1 minus 4 minus 3, which is equal to minus 1. Now next problem. Now when you apply x equal to 2 here, 2 cube 8 minus 16 plus 10, 18 minus here 18, which is 0 by 0 form. Means 0 is a root of this polynomial as well as this polynomial. That means x minus 2 is a root of the polynomial in the numerator as well as the polynomial in the denominator. So hence x minus 2 is one of its factor. To get the remaining, you can try 1. First write the coefficients. Minus 4, 5, minus 2. Then as 2 is a root, write this one as it is. 2 ones are 2, minus 2. Then minus 4, 2 2s are minus 4. That is 1, 2 ones are 2. So this gives you 0. Means 2 is a root. Therefore, factors are x minus 2 into x square minus 2x plus 1. This is how to get the remaining. Similarly, for the denominator, 1, x cube coefficient is 1, x square coefficient is 0, x coefficient is minus 2, then constant is minus 4. 2 is a root of this polynomial also. So 2, write this one as it is. 2 ones are 2. 0 plus 2 is 2, 2 2s are 4, minus 2 plus 4 is 2, 2 2s are 4. That means minus 4 plus 4 gives you 0. Hence x minus 2 is here also it is a factor. Then x square plus 2x plus 2. Therefore, now that factor gets cancelled from the numerator as well as from the denominator, apply the limit. So this cancels. Apply the limit 2 square 4 minus 4 plus 1 divided by 4 plus 4 plus 2. So anyway, this cancels. This is equal to 1 plus 1 by 10 is the answer. Now the next method is least common multiplier method, that is LCM method. This is usually applied when you get infinity minus infinity kind of indeterminate form. Let's see one example. Evaluate, limit extends to minus 2. This is the function. When you put x equal to minus 2, 1 by minus 2 plus 2, that is 1 by 0 is infinity, minus 6 by, this is minus 2 whole cube is minus 8 plus 4 minus of minus plus 4, minus 8 plus 8, which is 0. So 6 by 0 is infinity. So you will get infinity minus infinity form. Therefore, now you have to take LCM, limit, as the name says, least common multiplier method, extends to minus 2, 1 by x plus 2 minus 6 by, take x common, x square plus x minus 2. Okay, before taking LCM, let us factorize this denominator. Limit extends to minus 2, get 1 by x plus 2 minus 6 by x into your plus 2x minus x. The factors are like this: x square plus x minus 2, x square plus 2x minus x minus 2, because 2 ones are 2 into minus 1 is a minus 2, 2x minus x gives you x. So x into x plus 2 minus 1 into x plus 2. So factors are x plus 2 into x minus 1. So I'll get x plus 2 into x minus 1 into this x. Now LCM, I have to take LCM here. Limit extends to minus 2. The product of factors, x plus 2, one common factor, then x minus 1 into x. This is the LCM. Okay, because x plus 2 already it is there in both these terms, so that I have written on once. Then extra linear factors, x minus 1, x. So this has to be multiplied with x plus 2 is already there. So remaining x minus 1 into x, okay, minus 6. X plus 2 is already there. X minus 1 is there. X is also there. So it is just 6. So this gives you limit x extends to minus 2. We can directly apply the limit here. Apply the limit and check what value you get. Extends to minus 2. Divide this. X square minus x minus 6 divided by x into x plus 2, x minus 1, because directly if you apply, again you will get that 1 by 0 here. So first let us simplify. After taking LCM, let us simplify. So it is x square minus x minus 6. So you have to factorize this also. X square, 3 2s 6, minus 3x plus 2x minus 6. So 3 2s minus 6, minus 3 into 2 is minus 6, then minus 3 plus 2 is minus 1, x into x minus 3 plus 2 into x minus 3. So x minus 3 into x plus 2. So numerator becomes limit extends to minus 2. This is x minus 3 into x plus 2 divided by x into x plus 2 into x minus 1. So x plus 2 cancels. Now the factor which was making the numerator and denominator both 0 is getting cancelled. So now apply the limit. X is minus 2. Minus 2 minus 3 is minus 5 divided by minus 2 into, this is minus 2 minus 1 minus 3. So minus minus cancels. 3 2s are 6. So it is minus 5 by 6. The final answer is minus 5 by 6. Now the next method, rationalization method. This method is applied when you have any terms having the square root function. See, consider this problem. Evaluate, limit extends to 0. The function. When you apply the limit, x is 0, square root of 4 is 2 minus 2 by 0, which is 0 by 0 form. That is an indeterminate form. Therefore, what I'll do is, let me rationalize it. Minus 2 divided by x. Rationalization is done by writing the conjugate in the numerator as well as in the denominator. That is 4 plus x plus 2 divided by 4 plus x plus 2. It was minus here, so I took a plus. Now limit extends to 0. This is a minus b, a plus b. So you will get a square plus a square minus b square. So minus b square is 2 square divided by x into square root of 4 plus x plus 2. So this is equal to, this value cancels here. This value square root and square cancels. So 4 plus x minus 4, limit extends to 0 divided by x into square root of 4 plus x plus 2. So minus 4 plus 4 cancels. Apply the limit extends to 0. So x also cancels, otherwise you will get a 0 again, 0 by 0 form. X also cancels. Now apply the limit. Square root of 4 plus 0 is square root of 4. 2 plus 2 is 4. So answer is 1 by 4. Now similarly, one more problem. When you apply the limit here, this function involves square root. So the rationalization method, and it is giving an indeterminate form. Root 5 minus root 5 is 0. 2 minus 2 is 0. It is 0 by 0 form. So you will get limit extends to 2 root of 3 plus x minus root 5 divided by x minus 2 into root of 3 plus x plus root 5 divided by root of 3 plus x plus root 5. So this gives you limit extends to 2 a minus b, a plus b. So a square minus b square minus root 5 whole square divided by x minus 2 into root of 3 plus x plus root 5. So this gives you square root square cancels, limit extends to 2. 3 plus x minus 5 by x plus x minus 2 into root of 3 plus x plus root 5. So x minus 5 plus 3 is x minus 2. This cancels with the denominator term. So extends to 2, apply the limit. That is root of 3 plus 2 is 5. Root 5 plus root 5. 1 by 2 root 5 is the answer. Now next is use of some standard results to evaluate some of the limits. See, these standard results we will be using to evaluate the given limits. You have to memorize all these standard formulae. Limit extends to x power n minus a power n by x minus a is n into a power n minus 1. Limit theta tends to 0, sin theta by theta or theta by sin theta both gives you 1. Theta tends to 0, tan theta by theta or theta by tan theta gives you the value 1. Limit extends to 0, a power x minus 1 by x is log a. E power x minus 1 by x is log of e to the base e, which is 1. Next, log of 1 plus x by x as x tends to 0 value is 1. This is already proven and we are making use of those results. That's it. Extends to 0, 1 plus x to the power 1 by x. What value you had here, the reciprocal should be in the power. So that gives you e. Similar limit extends to infinity. This is inside 1 plus 1 by x. That's why infinity here. Here it was 0. To the power x equal to e. When you apply the limit, it gives you 1 to the power infinity form. So in both cases the value is e. Now let us solve few problems. I am going to apply the first formula for this. That is because x tends to 3. Here you have x power 5 minus, this is 3 to the power 5 divided by x power 4 minus 3 to the power 4. When you want to apply this first formula, you should have x minus a in the denominator. Here value of a is 3. Therefore, x minus 3 should be in the denominator. What I'll do is, I'll rewrite this as x to the power 5 minus 3 to the power 5 by x minus 3 whole divided by x power 4 minus 3 to the power 4 by x minus 3. So that this x minus 3 cancels and you will get the same thing back. So now this is of this form, first result form. You can split the limit to the numerator as well as to the denominator. That is algebra of limits. Limit of f of x by g of x is limit of f of x by limit of g of x. So here n value is 5 and a value is 3, 5 minus 1. Here 5 into 4 into 3 to the power 4 minus, that is equal to 5 by 4 into, this is 3 to the power 4 by 3 to the power 3. 3 cancels, 1 3 remains. 15 by 4 is the answer. Now similarly, the second problem is sin 4x divided by 3x as x tends to 0. We have the result theta tends to 0. Sin theta by theta is equal to 1. What angle you have here, the same angle should be in the denominator. Now your angle is 4x, here you have 3x. But I want 4x, x tends to 0. So let me keep that 1 by 3 outside. So you will get sin 4x divided by x. I want 4x in the denominator, so multiply by 4 and divide by 4. Now apply the limit. This value is 1, so value is 4 by the outside value 3. Now see the third problem. Limit x tends to 0, 1 plus 8x to the power 1 by x. Let me make use of this seventh formula, that is limit x tends to 0, 1 plus x to the power 1 by x is always equal to e. So here in this case x tends to 0, 1 plus, this is 8x. You have 8x to the power. The reciprocal of this term should be in the power. Reciprocal of 8x is 1 by 8x, but you have just 1 by x here. So multiply by 8 and divide by 8. So what we'll get is the limit x tends to 0, 1 plus 8x to the power 1 by 8x whole power 8 you have. So this is e. So answer is e to the power 8. Now similarly here, tan 3x by sin 2x. So split the limit x tends to 0, tan 3x divided by limit x tends to 0, sin 2x. We know that tan theta by theta is 1. The limiting value of sin theta by theta is 1. But here angle is 3x. So divide by 3x, multiply by 3x. Here also angle is 2x. Multiply by 2x and divide by 2x. As x tends to 0, 3x also tends to 0. As x tends to 0, 2x also tends to 0. Now x cancels. Tan theta by theta, this value is 1. This value is 1. So the remaining is 3 by 2. This is the answer. Now fifth problem is limit x tends to 0, ab power 3x minus 1 divided by x. I am going to use the standard form limit x tends to 0, a to the power x minus 1 divided by x, which is equal to log of a. This is the formula I am going to use here. So now compare this with the formula, the standard form. Here in the place of a, you have the constant ab. That is the only difference. So this gets replaced by ab. But before replacing that, ab to the power 3x, a to the power x is the same value you have it in the denominator here. But here you have ab power 3x. So 3x should be there in the denominator. But x is there. Minus 1 as it is, which is there in the both the forms now. So what I'll do is limit as x tends to 0, ab power 3x minus 1 divided by, I want 3x here, so you multiply by 3 and divide by 3. So 3 cancels, you are going to get the same thing back, but we have converted the given function into our required form. So 3 is extra here. You can keep 3 outside. Limit is x tends to 0, ab power 3x minus 1 divided by 3x. So as per this form, the value of this should be log of ab, because A is a constant here, AB is also a constant, just that is the difference. So a power x minus 1 by x as x tends to 0 is log A. So here the constant is AB, hence log AB. So answer is 3 log AB. Now here in this problem, I'm going to use two standard form. One is limit as x tends to 0 log of 1 plus x divided by x, this form, and one more is limit x tends to 0 e to the power x minus 1 by x, which is log of e, that is nothing but 1. And this value is also equal to 1. Let us make use of these two standard forms to solve this problem. Always you should compare the given function to the standard form. See here, log is there, 1 plus, instead of x you have 8x square. And the same quantity is to be divided by. So divided by x. So you should have here divided by 8x square. So that is missing. 8x square is missing. And similarly here you have e to the power x square minus 1. So in this form e to the power x you have. So instead of x you have x square now. So divided by what you should have? X square you should have. What power you have in the e? So with the e. So the same value to be in the denominator. So I should have x square in the denominator. So what you should do, you see, limit x tends to 0 log of 1 plus 8x square divided by 8x square. I need that into 8x square. So it is balanced. Because extra I am writing this 8x square means something you should multiply by the same amount. So it cancels, you will get the same thing back. Divided by now. Similarly, e to the power x square minus 1. I want x square, so divide by x square and multiply by x square. Now the limit will apply both for numerator as well as denominator, that is by the algebra of limits. So you will get limit as x tends to 0. Apply the limit for the numerator as well as for the denominator. See here, this x square cancels. So log of 1 plus 8x square divided by 8x square whole divided by, then limit x tends to 0 e to the power x square minus 1 by x square. So here 8 is extra. Let me write it here, 8 into this value. So this is equal. Now apply the limit. What is value of this limit as per the standard form? It is equal to 1. So 8 into 1 after applying the limit divided by this value is also equal to 1. Hence you will get the final answer as 8. This is how we evaluate some of the limits using the standard form. All you need to do is you have to remember these standard forms and compare the given function with any one of these standard forms. If it is not directly in the standard form, try converting it into a standard form by some rearrangements or by multiplying or dividing some of the required terms. Now let's see the concept of infinite limit. We have here limit of 1 by x as x tends to infinity is always equal to 0 because 1 by infinity is 0. Similarly, limit of 1 by x to the power n as x tends to infinity is always equal to 0 where n is greater than 0. Using this result only, it is extended to 1 by x to the power n also. Therefore, in these two cases, there exists limit x tends to infinity. So, such limits are the limits having infinity as its limiting value. So now evaluate this limit. So in this case, limit extends to infinity. So infinite limit here. So degree of numerator and degree of denominator equal. So this is the highest degree term. Let me take it outside. 3 plus 5 by x minus 1 by x square. So x square cancels 1 back. 1x cancels 5x back like that. Similarly, from the denominator, take x square common. 3 by x plus 9 by x square. So x square cancels. The term which was making both numerator and denominator infinity by infinity form, that goes off now. Now apply the limit. 3 plus 5 by infinity is 0 minus 1 by infinity square is also 0. using this result 1 by x to the power n. So similarly, they were divided by 4 minus 0 plus 0. So the answer is 3 by 4. Consider one more problem. Limit extends to infinity. This is the function. So now limit extends to infinity. Degree of numerator is more than the degree of denominator. So the common value is x cube. Take x cube outside. Then 5 into x square plus x. So 1 by x square. Square x square cancels. 1x remains plus 1 by x cube divided by x cube common 1 plus 5 by x cube. So now x cube cancel. Apply the limit. Anyway, this is 5 by infinity, it is 0. 1 in the denominator. Numerator, you see, all these values are 0, but 5 into infinity square, that is infinity. So which is equal to infinity. So when the degree of denominator and degree of numerator are equal, these coefficients, quotient, you will get it as answer. When degree of numerator is greater than degree of denominator, in that case infinity is always the value of that limit. If degree of numerator is less than the degree of denominator, then you can check with any of the problems. It is 0 becomes the answer. 1 by infinity it becomes 0 is the answer. Next is concept of left hand and right hand limit. So far we directly apply the value of the variable x as x tends to a, though we had it, we apply directly x equal to a and we found the value of the limit. That is because from both left hand side and right hand side it was approaching to the same value because one single function was given. But in case if there are two different functions for one particular value, like if the value is splitted as greater than some particular value one function, less than some particular value another function, in such cases you always have to find out left hand and right hand limit, and if both are equal then only the limit exists. You consider the simplest function, that is modulus function. So modulus function is given by x if x is positive or equal to 0, minus x if x is negative. For all negative input, output is minus of minus x, so it gives you positive value. For all positive inputs, output is already positive. So modulus function gives you only the positive output. This is how the graph of the modulus function looks. What is the function's limit as x tends to 0? So we have to find out LHL, limit of f of x as x tends to 0 from the left. X is less than 0. When x is less than 0, what is the value of the function? Minus x. Apply x equal to 0. Minus 0, which is nothing but 0. Similarly, RHL equal to limit of f of x as x tends to 0 from the right. Means x is greater than 0. When x is greater than 0, we have to take the function x. So apply the limit x equal to 0, which is 0. So in both cases, LHL equal to RHL. Hence, limit of f of x as x tends to 0 exists and it is equal to 0. Now next question, evaluate limit of f of x where f of x is given by this. Means when x equal to 1, the function value is x square plus 1. Even if x is less than 1, it is x square plus 1. When x is greater than 1, for all values greater than 1, the function is 1 minus x square. So there are like two different functions for the real numbers, for less than 1 and greater than 1 and equal to 1. So therefore, we cannot directly substitute the value of x here. We have to find out LHL. From the left side when you approach 1, it is different function. From the right side when you approach function 1, it is different function. Therefore, LHL is limit extends to 1 from the left. X is less than 1. I will choose the function x square plus 1. So 1 plus 1 it is 2. RHL is equal to limit extends to 1 from the right. I have to choose the function 1 minus x square greater than 1. So this is equal to 1 minus 1, which is nothing but 0. So here in this case you can see LHL not equal to RHL. Hence limit of f of x as x tends to 1 does not exist because LHL not equal to RHL. Now next question is, if limit of f of x as extends to 3 exist, so it is given in the question, then find a where function is given this. So it is given limiting value of the function as extends to 3 exist. It means LHL exists, RHL exists, and both are equal, and common value is a limiting value of the function. Therefore, we have to find out LHL, we have to find out RHL, then equate LHL and RHL, then find the value of A using that. Limit f of x as extends to 3 from the left, means x is less than 3. When x is less than 3, I will choose this function, that is limit as extends to 3 from the left, ax plus 3. Substitute now x equal to 3, 3a plus 3. This is LHL. Now RHL is equal to limit of f of x as extends to 3 from the right, x is greater than 3. When x is greater than 3, I will be choosing this function. X tends to 3 from the right, so 2 into x plus 1. Now as it is a polynomial function, direct substitution of the limit. Put x equal to 3, 2 into 3 plus 1 is 4, which is equal to 8. Now, as the limit of the function exists, which is already mentioned in the question, therefore LHL must be equal to RHL. LHL equal to RHL. So this implies 3a plus 3 equal to 8. 3a equal to 8 minus 3, which is 5. A equal to 5 by 3. This is the answer. Now about continuity of a function at a point. A function, graphically, a function f of x is said to be continuous if you can draw the graph of a function without any break. For example, if you want to draw a straight line passing through the origin, that is y equal to x is the equation of that straight line, then you can draw the graph of this straight line without any break. Hence, we call this function as continuous function. But every time we can't draw the graph of the function. So algebraically, we say that a function is continuous at a point x equal to a if limit of f of x as extends to a equal to f of a. Limiting value of that function at the point as extends to a must be same as the value of the function at x equal to a. If this condition satisfies, then we say that the given function is continuous at x equal to a. Now you can see the graph. Limit of a function exists only if LHL equal to RHL. So this is your LHL. From the left side, we are moving to the point A. So LHL is tending towards some value. RHL is also tending towards some other value. Function value is here, which is included here, shaded like this. So RHL and function value is same, but LHL and RHL are different. Means there is a break in the graph of the function. Hence this function is not continuous. Similarly here, LHL and RHL both are same because both are moving towards the same value. But value of the function at a point A is just, it is a bubble, not shaded. Means it is not defined. Hence the function is not continuous. But in this case, LHL and RHL both are going towards the same value, and function is also having the same value because it is, the bubble is shaded, means that point is included. Hence this is the graph of a function which is continuous. So using the algebraic definition of continuity, we say that the function is continuous if limiting value of the function is equal to the value of the function at that point A. So you have to find out LHL at A and RHL at A. Then LHL must be equal to RHL, and that should be equal to the value of the function. Let us see some problems. Discuss the continuity of the following functions. You have to check, is modulus function continuous at x equal to 0? We know that graph of a modulus function is in V shape. You can draw the graph of a modulus function without any break. Hence, this function is continuous. But algebraically, we have to prove that is modulus function continuous at x equal to 0. So you have to find out LHL of this function, that is limit of f of x as x tends to 0 from the left, means x is less than 0. So which is equal to limit x tends to 0 from the left. Modulus function has two values, x if x is greater than or equal to 0 and minus x if x is less than 0. So x is less than 0 means value of the function is minus x, I will choose. Now apply the limit, it is minus 0, which gives you 0. Similarly, find out RHL, which is equal to limit of f of x as x tends to 0 from the right, means x is greater than 0. As there are two values for the function, we can't do the direct substitution method. That's why I am finding LHL and RHL separately. So function value x greater than 0 is x. Substitute x equal to 0, we will get 0. Minus 0 plus 0, whatever it is, value is 0. So LHL equal to RHL and the common value is limiting value of a function. Therefore, limit of f of x as x tends to 0 equal to 0. Is it same as the value of the function at x equal to 0? What is the value of the function at x equal to 0? When x equal to 0, function is x. So x equal to 0 means function is 0. Hence, this is f of 0. Function value at the point 0 and its limiting value both are equal and the function is continuous at x equal to 0. From the graph we can see here that at x equal to 0 there is no break in the graph, hence it is continuous. Similarly, now another function is mod of x minus 3 at x equal to 3. Modulus function, you can remember that modulus function are all continuous function. So it is x or x minus a, x minus 5, anything. So x minus 3, first let me write the definition of mod function when it is x minus 3. When x minus 3 is greater than or equal to 0. Same thing applied here, but instead of x you have x minus 3. Similarly, x minus 3 with a minus sign if x minus 3 is less than 0. So modulus function has two outputs. So you will get x minus 3 when x is greater than or equal to 3 and 3 minus x. I'll take the minus inside if x is less than 3. I got two different values for the function. Now find out LHL. LHL is x less than 3 here. X tends to 3. Limit x tends to 3. From the left, which function you will choose? 3 minus x. Substitute. 3 minus 3 is 0. RHL is equal to limit x tends to 3 from the right. X minus 3, that is 3 minus 3. This also gives you 0. Now LHL is equal to RHL and limit of f of x as x tends to 0 equal to 0. Is it same as the function value at x equal to 3? What is function value at x equal to 3? At x equal to 3, I will choose this function. Put x equal to 3, 3 minus 3. That also gives you the value 0. So, limiting value of this function at as x tends to 3 is same as the value of the function at x equal to 3. Hence, the function is continuous. Now find the relation between a and b such that this function is continuous at x equal to 0. So they already had given here in the question, function is continuous means limiting value of the function at x equal to 0 is same as the value of the function at x equal to 0. So this means LHL and RHL both are equal. So first let us find out LHL. Limit x tends to 0 from the left. X is less than 0 means I will choose this function ax plus b plus 3. Now substitute x equal to 0, you will get b plus 3. Now RHL equal to limit x tends to 0 from the right greater than 0. This is 2x minus 2. I will choose this function 2x minus a. This is a. So put x equal to 0, you will get minus a. Now LHL equal to RHL, that is because the function is continuous, so limiting value exists. So b plus 3 must be equal to minus a, that is nothing but a plus b plus 3 equal to 0 or a plus b equal to minus 3. This is the relation between a and b when the function is continuous at x equal to 0. That is about continuity of a function at a particular point. Now, continuous function means a function is said to be continuous if it is continuous at each point of its domain. See, for example, the domain of modulus function is all real numbers. R to R, it is a function. So, f of x is equal to mod x. Now, this mod x is continuous function because we can have the graph of this function on this plane without any break. So for every real number there exists another point, another output. Hence this function is a continuous function. That was the continuity of a function at a point. Now this is the continuity of a function in general, that is everywhere, in the sense the entire domain. At each and every point, if there is no break in the graph, we say that the function is continuous function.